So the trick with numerical expressions and writing numerical expressions is to think of them like a puzzle and breaking them down into its multiple sections. There's a couple key vocabulary words you're going to need when you're thinking about numerical expressions, and that is the sum, the difference, the product, and the quotient. Those are your four main terms that you're going to use when you're doing numerical expressions. Those aren't going to be your only ones. You will see other words, but those are tend to be the most difficult and the most consistent that you'll see over and over again. Sum, meaning addition, difference, cluing subtraction, product, bringing in multiplication, and then quotient is division. So when you see those words, they should alert you that you're going to use a certain operation. Note that it's written in this format, the sum of blank and blank, meaning that if I wanted you to show me the sum of 2 and 1, that would mean 2 plus 1. I'm not saying 2 sum of 1. I don't replace the add with the sum of. I phrase it in a different way. The sum of the difference of the product of is always going to go before you see the numbers, and then you list the numbers. So the sum of 2 and 1 can be written as 2 plus 1. The difference of 2 and 1 can be written as 2 minus 1. The product of 2 and 1 is 2 times 1. And then lastly, the quotient of 2 and 1 would be 2 divided by 1. So you have to be able to go from a written expression to a numerical expression. And granted, you're not always just going to see these words. You're going to see other ones. And you have to be able to apply everything that you know to deciphering these number puzzles. So think of the problem: 3/8 times the sum of 1/3 and 2/8. 3/8 times the sum of 1/3 and 2/8. So looking at this phrase, you need to identify what you can right away translate. So I look at this and I see 3/8 times. I know that's going to entail going 3/8 times something. They're not even making me use the product of. They're just saying times. So they're making it nice and easy for us. 3/8 times. The second part of my equation here is the sum of 1/3 and 2/8. Well, looking at my example, we did the sum of 2 and 1 written as 2 plus 1. So the sum of 1/3 and 2/8 should be able to be written as 1/3 plus 2/8. The sum of 1/3 and 2/8, 1/3 plus 2/8, it looks right to me. The only thing you're missing is some parentheses, because you should always put parentheses around parts of your word problem that are grouped together. So when it says the sum of, that means they want you to do that first. So you're going to put parentheses around that. Anytime you see any of these, the sum of, the difference of, the product of, that's your clue to put parentheses around them. So 3/8 times 1/3 plus 2/8. Another example we can do is subtract 8 from 1/5 of 12. Subtract 8 from 1/5 of 12. So again, let's break it up into its pieces. You can either start from left to right or find whatever stands out to you. For me, I see subtract 8 first. And what I notice right away is I know they're trying to trick me. Because when you see subtract, you're always going to think that you're going to do something like 8 minus. But that's not what they're asking me to do. They're telling me to take away 8 from this number. So instead of writing 8 minus, I'm going to write minus 8. Because I know subtract 8 is going to be equal to minus 8. So whatever this is, I'm going to minus 8 from. And they want me to subtract it from 1/5 of 12. Well, 1/5 of 12, I know 1/5 can be written as 1/5 of 12. And then I know from all my previous knowledge of fraction multiplication, whenever they give me an of like this, they're virtually telling me to multiply. So I know 1/5 of 12 is really 1/5 times 12. So here are my two pieces, minus 8 and 1/5 times 12. So I'm going to combine them together, knowing that minus 8 has to be connected. That minus sign can't be floating. I need to connect it on to my equation. So I'm going to do 1/5 times 12 minus 8. And again, I'm going to use my parentheses rules. Whenever they give me a grouping of something, I'm going to put them in parentheses. So in this situation, my 1/5 times 12 is grouped. So I'm going to do 1/5 times 12 minus 8. Let's try one more, and we'll practice going from words to numbers. So if I had something like 4 times the quotient of 1/3 and 3/4. I can again break this into pieces. 4 times the quotient of 1/3 and 3/4. Well, 4 times is telling me I'm going to do 4 times something. That's a pretty straightforward one. The quotient of 1/3 and 3/4. That's what I'm going to have to remember of my 4 key words. Quotient meaning division. So the quotient of 1/3 and 3/4 means I'm going to take those two things and I'm going to divide them. Now, what's tricky with these is you want to write them in the order that they give them to you. I can't flip these around because it does matter what order you divide things in. So I'm going to keep 1/3 first because they gave it to me first. And then I'm going to divide, because it's quotient, by my second number. So 1/3 divided by 3/4. That brings up my second part of my problem. So now I have 4 times 1/3 divided by 3/4, and I can combine them together and get 4 times 1/3 divided by 3/4. So numerical expressions with fractions aren't that tricky once you know your terminology. If you memorize your terminology, your sum of, your difference, your product, and your quotient, and you just break it down into its pieces, it isn't too challenging, besides making this sometimes errors of confusing pieces of information. For example, something that was confused a lot of the times is when they give you a secret of, or they assume that you remember that there's an of. For example, if you saw the equation 3/4 the sum of 4 and 5. 3/4 the sum of 4 and 5. So breaking this apart, I see right away the sum of 4 and 5, and I know sum is addition. So I'm going to go 4 plus 5. That leaves me with this floating 3/4 here. And they don't give me any other operation. They don't give me a times. They don't give me another product of, or a difference, or a doubled, or anything. They just give me this 3/4. So you're going to have to do some inferring based off the information that they give you. 3/4 the sum of 4 and 5. In this situation, there's what I like to call my secret of. 3/4 of the sum of 4 and 5. Sometimes they like to trick you and make you forget that ofs exist because they're not technically needed grammatically, so they like to pull them away. And we know if we had seen that of there, we would have multiplied. But because it's a secret of, you also need to think, I need to multiply. So 3/4 of the sum of 4 and 5. Well, 3/4 of means I do 3/4 times 4 plus 5. You can't assume that because it says sum, that means you're going to just have addition. You're not. You're going to have addition in the area that it requires, and then you need to use the rest of the problem to figure out what's left over. In this situation, you're left with 3/4 and your secret of to know that it's 3/4 times 4 plus 5. You're going to get that same thing over and over again in problems that look like 1/3 the difference of 1/2 and 1/3. Well, the difference of 1/2 and 1/3 I know is going to be 1/2 minus 1/3. Well, this situation again, I pulled off that whole part of the problem, leave me just with a 1/3. If they just leave you with a fraction, you can assume that there's a secret of 1/3 of the difference of 1/2 and 1/3. And that tells me I'm going to multiply, because I know that of means multiplication. So use what you know to solve your numerical expressions. Break them into pieces. Generally, you'll have 2 pieces. Sometimes they like to trick you with 3. But find what you know and translate it, and then look at what's left over. And that'll help tell you what operation, what numbers you need to do to finish solving your problem.